Imagine a world plunged into darkness, where the sun shines with no more brilliance than a full moon, where crops wither in the fields, where snow falls in summer, and where the very fabric of civilization begins to unravel. The year is 536 CE, and something catastrophic has happened, something that will reshape the course of human history, though most people alive today have never heard of it. History records this moment as the beginning of the darkest period in the last 10,000 years, a time when the sun disappeared, when winter claimed all seasons, when famine swept across continents, and when death followed closely behind. Byzantine historian Procopius wrote from Constantinople, "The sun gave forth its light without brightness, like the moon, during this whole year." His words, clinical and detached, barely capture the terror of living through such unprecedented times. For the people experiencing it, the world seemed to be ending. There was no explanation, no warning. Just a mysterious fog that rolled across Europe, the Middle East, and parts of Asia, blocking the sun for 18 months. The temperature dropped dramatically. Summer temperatures fell by as much as 2.5 degrees Celsius. Crops failed across the northern hemisphere. Snow fell in August. Frost covered the ground in unlikely places. The world was dying. And it wasn't just 1 year. 536 CE was merely the beginning. The darkness continued. And then, just as humanity thought recovery might be possible, another catastrophe struck. Then another, creating a decade of darkness. Tree rings tell us the story today. In their frozen record, we can see that 536 CE marked the beginning of the most sudden and severe cold period in the last 2 millennia. Each ring, unnaturally thin, speaks of a time when life barely continued. But what caused this global catastrophe? What force could darken the sun itself? What event could trigger the coldest decade in thousands of years? And why have so many of us never heard about this pivotal moment in human history? Tonight we embark on a journey through time to uncover the mystery of 536 CE, to piece together evidence scattered across ice cores, ancient texts, tree rings, and archaeological remains, to understand what happened when the sun disappeared. We'll travel from the frozen lakes of Iceland to the scorched ruins of ancient cities, from the mountain peaks of Switzerland to the darkened halls of Byzantine palaces, tracing the fingerprints of catastrophe across the globe. This investigation spans multiple disciplines, bringing together climatologists, historians, archaeologists, volcanologists, and astronomers, all working to solve a mystery that changed the world and might hold crucial lessons for our future. The evidence has been hiding in plain sight for centuries, scattered through monastery records, buried in ice cores, preserved in ancient tree rings, and written in the genomes of ancient human remains, all telling fragments of the same story. Recent discoveries have finally allowed us to piece together these fragments, revealing a picture more catastrophic than previously imagined, and more relevant to our modern world than we might be comfortable acknowledging. What you're about to hear might sound like apocalyptic fiction, but it isn't. Every claim will be supported by evidence, every speculation clearly identified, as we separate fact from fantasy in this extraordinary chapter of human history. The year 536 CE didn't just change the climate. It reshuffled political powers, triggered mass migrations, transformed economies, altered religious landscapes, and may have even helped usher in the Dark Ages in Europe. Our journey will reveal how fragile civilization really is, how vulnerable we remain to certain types of catastrophes, and how quickly our ordered world can dissolve when faced with environmental collapse. A lesson perhaps more relevant now than ever. So join me as we peel back the layers of time, as we examine the evidence piece by piece, as we reconstruct the events that plunged the world into darkness, and as we consider what this ancient catastrophe might tell us about our own future. This is the story of 536 CE, the year that changed everything, the darkest year in recorded history, and a mystery that has taken nearly 15 centuries to unravel. Chapter 2. When the Sky Fell. What if I told you that a single year could alter the course of human civilization, that events lasting just months could echo through centuries? That the world as we know it was partially shaped by a catastrophe most people have never heard of? 536 CE stands as perhaps the most consequential year that history forgot, a pivot point when everything changed, when the natural order seemed to collapse, when the sun failed, when summer refused to come, when starvation became the norm. The stakes of understanding what happened in 536 CE extend far beyond academic curiosity. They touch on our very survival as a species, on our vulnerability to cosmic and geological forces, on how quickly our complex societies can unravel. If we truly grasp what happened then, we might better prepare for what could happen now. Because the forces that darkened the sky in the 6th century haven't disappeared. They've merely been dormant, waiting. When we look at our modern world, with its global supply chains, with its just-in-time delivery systems, with its densely populated cities dependent on constant resupply, we must ask, how would we fare if faced with a similar catastrophe? The answer is troubling. We might be even more vulnerable than our ancestors. Despite our technology, despite our science, despite our apparent mastery over nature, we remain at the mercy of forces we barely understand. Our food security is precarious. Most developed nations maintain less than a 6-month food supply. Most cities would run out in days. Our agricultural systems require predictable seasons. Our infrastructure depends on stable conditions. What happened in 536 CE matters because it reveals how suddenly everything can change. How a single volcanic eruption, asteroid impact, or similar event can trigger cascading failures. How invisible connections bind climate to food to society. The people of the 6th century had no warning, no satellites to track volcanic plumes, no climate models to predict cooling, no emergency response systems. They simply woke one day to find the sun dimmed and their world forever altered. We have advantages they lacked. We can see the warning signs. We can study the past. We can prepare. But only if we acknowledge our vulnerability. Only if we learn from history. Only if we take seriously what happened in 536 CE. Consider that this single year may have contributed to the fall of the Sasanian Empire, the retreat of Teotihuacan civilization, the collapse of the Eastern Turk Empire, the transformation of China's political landscape, the weakening of Byzantium. It may have set the stage for the rise of Islam, the reshaping of Europe, the abandonment of ancient cities, the emergence of new power structures, the rewriting of religious narratives to explain unprecedented suffering. Plague followed the climate disaster, perhaps the most devastating pandemic before the Black Death, the Justinian Plague, arriving in 541 CE, killing up to half the population of the Eastern Roman Empire, completing the transformation that 536 began. The connections between climate chaos, agricultural collapse, social breakdown, and disease are not coincidental. They represent predictable patterns, patterns we see throughout history, patterns we might face again. When food becomes scarce, people migrate. When people migrate, they spread disease. When disease spreads, social structures collapse. When social structures collapse, knowledge is lost. When knowledge is lost, darkness descends. This is not just ancient history, it's a warning, a dress rehearsal for disasters we still face. Volcanic eruptions still occur, asteroids still cross Earth's path, pandemics still emerge, and our complex civilization grows more interdependent, not less. What changes if we take 536 CE seriously? Our disaster preparedness, our food security policies, our understanding of climate vulnerability, our appreciation for how quickly things can change, our respect for civilization's fragility. Archaeological evidence suggests that after 536 CE, people abandoned specialized production. They reverted to subsistence strategies. They hoarded precious metals rather than trading them. They prioritized survival over progress. They entered survival mode. The evidence shows societies transforming, becoming more militarized, more localized, more focused on immediate needs. Innovation stalled, trade contracted, cities emptied, and humanity's trajectory changed. We must ask ourselves uncomfortable questions. How would our society respond to a similar crisis? What systems would fail first? How would we adapt? What would survive? What would be lost? Who would we become? History shows that such events are not just possible but inevitable. The question is not if but when. Not whether we'll face such challenges, but how we'll respond when we do. And whether we'll see the warning signs before it's too late. The story of 536 CE is both a mystery to be solved and a lesson to be learned. A window into how fragile our world really is, and a mirror reflecting our own vulnerabilities back at us, in ways we might prefer not to see. Chapter 3. Before the darkness. To understand the impact of 536 CE, we must first understand the world it shattered. A world poised between ancient and medieval. A world of empires and migrations. A world already in transition when catastrophe struck. The Roman Empire had fallen in the West just 60 years earlier. Its last emperor, Romulus Augustulus, deposed in 476 CE. But in the East, the Byzantine Empire continued, powerful and prosperous under Emperor Justinian I. Justinian ruled from Constantinople, the magnificent capital that Constantine had established 2 centuries earlier, a city of perhaps 500,000 people, with massive walls, spectacular churches, public baths, aqueducts, a living testament to Roman engineering. Justinian had ambitious plans. He sought to reconquer the western provinces, to restore Roman glory, to codify Roman law, to build architectural wonders like the Hagia Sophia. His reign represented the last great flowering of classical antiquity. In 534 CE, just 2 years before the catastrophe, Justinian's brilliant general Belisarius had reconquered North Africa from the Vandals. The following year, he invaded Italy. The dream of a reunited Roman world seemed within reach. Further east, the Sasanian Empire ruled Persia under King Khosrow I, a sophisticated civilization with advanced agriculture, elaborate irrigation systems, Zoroastrian fire temples, and a rivalry with Byzantium that stretched back centuries. To the north, various Germanic peoples had established kingdoms in the former Western Roman provinces, the Ostrogoths in Italy, the Visigoths in Spain, the Franks in Gaul, the Vandals in North Africa, adapting Roman institutions to their own purposes. In Britain, Anglo-Saxon migrants were gradually transforming the landscape, establishing new settlements, introducing new languages, creating the foundations of England, while Celtic peoples maintained their traditions in Wales, Scotland, and Ireland. In Northern Europe, Scandinavian peoples continued their pre-Viking existence, farming, fishing, trading, building longhouses, creating elaborate jewelry, and developing the runic writing system that would record their language. Far to the east, China was divided between northern and southern dynasties, a period of political fragmentation following the collapse of the Han Empire. Yet Chinese civilization maintained its cultural continuity, its bureaucratic traditions, its technological innovations. In Mesoamerica, the great city of Teotihuacan dominated the Valley of Mexico, a massive urban center with perhaps 125,000 inhabitants, with monumental pyramids, organized city planning, and influence stretching across Central America. The Maya civilization was entering its classic period in the Yucatan Peninsula and Guatemala, building temple complexes, developing sophisticated mathematics, creating their intricate calendar system, recording historical events on stone monuments. In Peru, the Moche civilization created elaborate irrigation systems, golden artifacts of astounding craftsmanship, and painted pottery documenting their daily life and religious practices, their society thriving along the northern Peruvian coast. This was a world connected by trade routes, silk from China reaching Rome, spices from India arriving in Alexandria, African ivory appearing in Persian palaces, a complex network of exchanges linking distant civilizations. This was also a world of innovation, where water wheels powered mills, where ships crossed oceans guided by the stars, where architects created domes spanning unprecedented distances, where scholars preserved and expanded ancient knowledge. In Constantinople, scholars maintained the tradition of Greek learning. In Alexandria, mathematicians developed new theorems. In Ctesiphon, physicians combined Greek, Indian, and local medical traditions. In Chang'an, astronomers charted the heavens with precision. Religion was transforming this world. Christianity had become the dominant faith throughout the Mediterranean. Buddhism spread along the Silk Road. Hinduism evolved in South Asia. Zoroastrianism prevailed in Persia. Each tradition adapting to local conditions. The world of 536 CE stood at a crossroads, between ancient and medieval, between classical and feudal, between the world that was and the world that would be, unaware of the catastrophe about to strike. This was not a primitive world. It contained sophisticated civilizations, engineering marvels, philosophical traditions, literary masterpieces, artistic achievements, the accumulated wisdom of thousands of years of human development. And then, in a single year, everything changed. The sun dimmed, the temperatures dropped, the crops failed, and the world that had taken millennia to build began to unravel, faster than anyone could have imagined. Chapter 4. The First Signs. The first evidence of catastrophe appears in the Mediterranean basin, in the spring of 536 CE, when something unusual began to happen to the sun, something unprecedented in living memory, something terrifying. Procopius, a Byzantine historian in Justinian's court, recorded the phenomenon with clinical precision. The sun gave forth its light without brightness, like the moon, during this whole year. His words capture the eerie quality of the dimmed sun. And it seemed exceedingly like the sun in eclipse, Procopius continued, for the beams it shed were not clear. This was not a normal astronomical event, not a simple eclipse that would pass in hours, but something far more persistent and disturbing. Across the Mediterranean world, people looked up to see a sun robbed of its power, a pale disk barely visible through a haze that spread across the sky, a strange twilight that persisted through what should have been bright summer days. In the British Isles, far from Constantinople, the Annales Cambriae, Welsh annals, recorded the year when the sun was darkened. A simple entry that speaks volumes about how striking the phenomenon must have been to merit such mention. Chinese records from the Nanshi, history of the southern dynasties, reported yellow dust rained down like snow, while elsewhere they noted famine erupted and there was a rebellion in the eastern cities. Different symptoms of the same global catastrophe. Cassiodorus, a Roman statesman, wrote with growing alarm to his agricultural officials, "We have had winter without storms, spring without mildness, summer without heat." He described crops withering under a wan sun and famine threatening the land. The darkness was not a local phenomenon. It stretched across continent, from Europe to Asia, from North Africa to Scandinavia, a truly global event recorded independently by observers who had no contact with each other. Modern science confirms these ancient accounts. Ice cores drilled from Greenland, and Antarctic glaciers contain layers of ice that fell as snow in 536 CE. And these layers contain unmistakable evidence of catastrophe. Sulfur compounds and ash particles. These ice cores tell us something struck that year, something that ejected massive amounts of dust and aerosols into the upper atmosphere, something that circled the globe, something that reflected sunlight back into space, something that changed everything. Tree rings provide further confirmation. Dendrochronologists study the growth patterns preserved in ancient trees, and what they find in trees that lived through 536 CE is stunning. A dramatic narrowing of growth rings, evidence of severe cold. An Irish oak chronology shows the narrowest ring in the 1500 years occurred in 536 CE. Alpine oaks show the same pattern, as do Scandinavian pines. Trees from different species, different elevations, different continents, all telling the same story. The temperature drop was severe. Reconstructions suggest summer temperatures fell by 1.5 to 2.5 degrees Celsius. This may not sound dramatic until you consider the global average temperature difference between our time and the last ice age is about 5 degrees. This sudden cooling triggered a cascade of environmental effects. Growing seasons shortened dramatically. Crops failed across the northern hemisphere. Alpine glaciers advanced. Sea ice expanded. Ecosystems shifted. Animal migrations changed. In northern Europe, pollen records show a dramatic decline in cereal cultivation. Archaeological evidence reveals abandoned farms, empty villages, a landscape returning to forest as human populations contracted. The beginnings of demographic collapse. The cooling persisted through 536, through 537, into 538. 18 months of darkness, of cold, of crop failure, of hunger, of increasing desperation. As food reserves dwindled, as winters claimed what should have been summers, and just when recovery might have been possible, a second disaster struck. In 540 CE, the skies darkened again. The temperature plummeted once more, creating what climatologists now call the Late Antique Little Ice Age. A profound cold period lasting decades. The evidence suggests we're dealing with not one event, but a sequence, a terrible coincidence of catastrophes, a cosmic bad luck that struck humanity at a pivotal moment, changing the course of civilizations, altering the flow of history. But what caused this darkness? What force could dim the sun itself? The leading theory points to volcanic eruptions of exceptional magnitude, eruptions that ejected millions of tons of ash and sulfur dioxide into the stratosphere. Ice core evidence reveals a distinctive sulfate spike in layers corresponding to 536 CE. Chemical analysis of these sulfates provides clues to their volcanic origin, and their distribution pattern suggests a massive eruption in the northern hemisphere. Recent research has narrowed the likely culprit. An Icelandic volcano appears to be the primary suspect for the 536 event, while evidence points to another massive eruption, possibly in North America, for the 540 event, a devastating 1-2 punch. But some researchers suggest an alternative explanation, or perhaps a contributing factor. Could a cosmic impact have played a role? An asteroid or comet striking Earth or exploding in the atmosphere? The evidence remains contested. What's not contested is the severity of the climate crisis that followed, or its impact on human societies, or the suffering it caused. The historical record is clear on these points, even if the exact trigger remains under investigation. As the darkness persisted, food supplies dwindled, social tensions mounted, political systems strained, and then, as if the climate catastrophe wasn't enough, a new horror emerged, something that would complete the transformation of the ancient world. In 541 CE, just as societies were struggling to recover from the climate crisis, the first cases of a strange new disease appeared in Egypt. Victims developed swollen lymph nodes, high fevers, delirium, before dying in agony. The Justinian Plague had arrived. The plague spread rapidly through the Byzantine Empire, through ports and trade routes, along the same networks that had once spread prosperity, now vectoring death, killing between 30 and 50% of the population in affected areas. The timing was not coincidental. Climate catastrophe had weakened populations, created malnutrition, forced migrations, disrupted ecosystems, creating perfect conditions for disease to emerge and spread. A deadly synergy of disasters. Emperor Justinian himself contracted the plague but survived. Many were not so fortunate. His dreams of reconquering the western provinces faded as his empire struggled with demographic collapse, as tax revenues plummeted, as armies dwindled. But the true horror was just beginning, as the plague continued to spread, as the climate continued to cool, as societies continued to fragment, as the ancient world continued to transform into something unrecognizable, something darker, something medieval. What happens next will reveal the true scope of the catastrophe, the full impact on human civilization, and the surprising ways that humanity responded to this existential threat. Some with resilience, some with innovation, some with despair. The mystery deepens as we examine how different regions experienced this global catastrophe, how some societies collapsed while others adapted, how new powers emerged from the chaos, and how the world was fundamentally and permanently changed. Chapter 5. Beyond the Ashes. As we delve deeper into the mystery of 536 CE, contradictions emerge, questions that challenge our understanding, anomalies that don't fit neatly into the volcanic eruption theory, evidence that suggests something more complex may have occurred. The first contradiction appears in the ice core data itself. While sulfate spikes clearly indicate volcanic activity, their pattern is unusual. Their distribution doesn't perfectly match known eruption patterns. Their chemistry contains unexplained elements. Researchers from the Desert Research Institute in Nevada found something strange when analyzing Greenland ice cores: microscopic particles of volcanic glass with a unique chemical signature, one that doesn't match known Icelandic volcanoes of the period. Dr. Robert Dull, a paleoclimatologist specializing in this period, notes, "The chemical composition suggests an eruption unlike those we typically see from Iceland, something with unusual magma composition, perhaps from a volcano we haven't identified." This raises our first major question: if not Iceland, then where? What volcano could have caused such widespread atmospheric effects? Why haven't we found its unmistakable geological signature? Why does the evidence remain so elusive? Another contradiction emerges from tree ring data. While showing clear evidence of cooling, the pattern doesn't precisely match what we'd expect from a volcanic winter alone. The cooling persisted longer, fluctuated differently, behaved unusually. Dr. Ulf Bündgen, a dendrochronologist at Cambridge University, points out, "The temperature depression lasted decades, not years. This suggests either multiple eruptions or additional factors amplifying the cooling effect, something beyond a single volcanic event." The historical accounts themselves present contradictions. Some describe a dim sun, others mention colorful skies. Some report dry fog. Others speak of unusual precipitation, different phenomena that might indicate different causes or multiple events. Michael McCormick of Harvard University's Initiative for the Science of the Human Past notes, "The Byzantine sources describe conditions that sound volcanic, but Irish chronicles mention events that sound almost cosmic in nature. The records don't align perfectly. Chinese astronomical records from the period document unusual celestial phenomena, stars visible during daylight, strange lights in the night sky, unusual cometary activity, observations not typically associated with volcanic eruptions alone. Japanese records mention yellow dust falling from the sky. Korean chronicles describe five-colored dust raining down. These accounts suggest particulate matter unlike typical volcanic ash, something containing unusual mineral components. Perhaps most puzzling are accounts from areas that should have experienced ash fall directly: Iceland, Northern Europe. Yet these regions report strange phenomena, but not heavy ash deposits, an absence of evidence where we'd expect it most. Archaeological excavations in Iceland have failed to uncover definitive evidence of a massive eruption dated precisely to 536 CE. Despite intensive searching, despite clear historical and climatological evidence that something catastrophic occurred, this doesn't disprove volcanic activity, but it does suggest our understanding remains incomplete, that we might be missing crucial pieces of the puzzle, that the story of 536 CE might be more complex than initially thought. Further complicating the picture are archaeological findings from around the world. Evidence of societal disruption appears in some regions before 536 CE, suggesting the catastrophe might have been the culminating event in a longer sequence of troubles. For instance, in Scandinavia, pollen records show agricultural decline beginning slightly before 536 CE. In Britain, Some settlements show signs of abandonment in the early 6th century. Timing that doesn't perfectly align with the main climatic event. Then there's the question of geographic distribution. While effects were global, they weren't uniform. Some regions suffered more than others, some recovered quickly, some never recovered. Patterns that aren't fully explained by climate alone. The Americas present particular contradictions. While Mesoamerican civilizations show evidence of disruption during this period, the timing doesn't precisely match the 536 CE event. Some changes began earlier, some later. The correlation is imperfect. Dendrochronologist Valérie Trouet explains, North American tree rings show the cooling signal, but with different intensity and duration than European samples, suggesting regional variations in climate impact that we don't fully understand. Another anomaly appears in the Black Sea sediment cores, where researchers found evidence of unusual microfossil assemblages during this period. Species patterns that suggest not just cooling, but complex changes in ocean circulation and chemistry. These sediment cores contain layers with unusual concentrations of certain metals, including iridium, a platinum group element typically rare in Earth's crust, but more common in extraterrestrial material, a finding that raises eyebrows among researchers. Iridium anomalies are often associated with cosmic impacts, like the one found at the KT boundary marking the dinosaur extinction. Though the 536 CE concentrations are much lower, they still represent a deviation from expected values. Could this indicate a cosmic component to the 536 CE event, a meteorite impact or airburst that coincided with or triggered volcanic activity? The evidence remains inconclusive, but the question persists. Ice cores from Antarctica show the climate signal, but with subtle differences from Greenland cores. Timing variations, intensity differences, chemical composition variations, suggesting complex global atmospheric dynamics during this period. These Antarctic cores contain microscopic particles that some researchers have identified as micrometeorites, tiny fragments of cosmic origin. Their concentration increases slightly during layers corresponding to the mid-6th century. Another puzzling anomaly. Cosmic dust constantly falls to Earth, but variations in its concentration or composition can indicate unusual astronomical events. The mid-6th century layers show both increased quantity and unusual composition, findings still debated among specialists. Paleoclimatologist Francis Ludlow of Trinity College Dublin notes, "We're seeing evidence that doesn't fit neatly into a single cause explanation. The data points to multiple factors converging to create this extraordinary period of climate disruption." Then there's the strange case of contemporary descriptions that don't sound volcanic at all. References to stars falling from the sky, to dragons fighting in the clouds, to blood raining down. Accounts dismissed as superstition but perhaps containing kernels of truth. Michael Siegel, an ice core specialist, suggests, we may be looking at a compound disaster, perhaps a volcanic eruption that coincided with another event. Their combined effects creating the unprecedented climate anomaly we see in the records. The Justinian Plague itself presents anomalies. Its emergence so soon after the climate catastrophe suggests a connection, but the specific pathway remains unclear. How exactly did climate change trigger or amplify this particular pathogen? Recent genomic studies of the Justinian Plague show it was Yersinia pestis, the same bacterium responsible for the later Black Death, but its specific strain and evolution path remain subjects of ongoing research. Another piece of the larger puzzle. As we examine these contradictions and anomalies, a more complex picture emerges, one where a volcanic eruption might be just one component, where multiple factors converged to create the darkest period in the last 10,000 years. Perhaps we're dealing with a perfect storm of catastrophes, a volcanic eruption coinciding with other events, their combined effects amplifying each other, creating impacts greater than any single disaster could produce. A cascade of calamities. And this leads us to consider possibilities beyond conventional explanations, to examine myths and legends from this period, stories that might contain encoded memories of what really happened when the sun went dark in 536 CE. Stories passed down through generations, preserved in cultural memory. Narratives that might seem fantastic to modern ears, but could contain kernels of truth about events too traumatic to be recorded in straightforward historical accounts. Chapter 6. Echoes in Myth. Throughout human history, catastrophic events have been preserved not just in historical records, but in myths, in legends, in cultural memories transmitted across generations, sometimes encoding actual events in symbolic language that outlasts written accounts. The events of 536 CE were so traumatic, so beyond normal experience, that they left their mark in the mythological frameworks of cultures around the world. Stories that might seem fantastical but contain kernels of historical truth. In Norse mythology, we find the concept of Fimbulwinter, a 3-year winter that precedes Ragnarok, the end of the world, a time when the sun turns black, earth sinks in the sea, the bright stars vanish from the sky. The poetic Edda, compiled centuries after 536 CE but preserving much older oral traditions, describes, "First will come the winter called Fimbulwinter. Snow will drive from all directions. The cold will be severe. The winds will be fierce." These descriptions bear striking resemblance to what actually occurred in 536 CE, when summer never came, when crops failed, when the sun dimmed. The timing suggests these myths might encode memories of real climate catastrophe. Norse archaeologist Neil Price notes, "The experience of the 6th century climate crisis likely reinforced or perhaps even generated aspects of Norse apocalyptic mythology, real climate trauma encoded in religious narratives that helped explain the inexplicable." Similar echoes appear in Celtic mythology. In tales of the Morrigan, who sometimes appears as a harbinger of doom shrouded in fog, in stories of blight and darkness descending upon the land, in legends of failed harvests and subsequent warfare. Irish annals blend history and mythology when describing this period, recording bare facts alongside supernatural interpretations. The Yellow Plague, attributed to divine judgment. The dimmed sun explained as the gods withdrawing their favor. Byzantine chronicles mention Emperor Justinian's face transforming into a featureless mask of flesh during this period, a detail dismissed as superstition, yet possibly describing the physical effects of plague that followed the climate catastrophe. In China, records from the Northern Wei dynasty speak of yellow dust raining like snow, while folklore from the same period tells of dragon battles in the sky, causing darkness. Different explanations for the same observed phenomena. These Chinese dragon battles merit closer examination. The description of dragons breathing fire and smoke in the heavens could poetically describe volcanic plumes, or the fiery entry of meteoric material. Actual events viewed through a mythological lens. Archaeological evidence from this period sometimes reveals unusual burial practices. Graves containing protective amulets. Ritual deposits unlike those before or after. Evidence of communities responding to perceived supernatural threats. In Mesoamerica, Maya monuments from the 6th century increasingly depict sky deities associated with disaster. Changes in iconography that correspond chronologically with the climate catastrophe. Cultural responses to environmental trauma. The Dresden Codex, a Maya manuscript compiled centuries later, contains astronomical tables and descriptions of world-ending catastrophes, including imagery of the sky dragon bringing floods and fire. Potentially preserving memories of earlier disasters. Archaeological excavations at Teotihuacan show evidence of ritual responses to crisis in the mid-6th century. Unusual offerings, changed ceremonial practices, modifications to sacred spaces, cultural adaptations to unexplained catastrophe. Christianity, the dominant religion in the Mediterranean world, interpreted these events within its apocalyptic framework. The darkened sun fulfilling prophecies from Revelation, the plagues matching biblical accounts, history seeming to confirm scripture. Gregory of Tours wrote, "There were signs in the sun, moon and stars, for the sun seemed diminished in brightness and appeared bluish in color. I believe these were signs of the coming of the pestilence that followed. Throughout Europe, church construction increased dramatically in the decades following 536 CE. Communities seeking divine protection, investing scarce resources in spiritual security, a pattern visible in the archaeological record across the continent. But perhaps most intriguing are the out-of-place elements in these accounts, details that don't fit the volcanic explanation, references that hint at cosmic phenomena, descriptions that suggest something beyond terrestrial causes. Persian chronicles mention stars falling like rain, a detail that could describe meteoric activity, a cosmic event coinciding with or perhaps triggering volcanic eruptions, a possibility that remains speculative but intriguing. Anglo-Saxon poems contain references to dragons crossing the sky during this period, to fire raining down, to stars falling to earth. Imagery consistent with meteoric or cometary phenomena rather than solely volcanic activity. The medieval Welsh poem, The Black Book of Carmarthen, contains lines that may reference this period. 7 suns were seen together, 7 moons together. On the day of Jesus' vengeance, heaven and earth shall tremble. These astronomical anomalies appear too frequently in too many separate cultures to dismiss entirely. They suggest something visible in the skies beyond volcanic dust, something that made a profound impression on observers worldwide. In Arabia, pre-Islamic poetry contains references to a period when the sun rose diseased, when stars appeared at midday. Observations recorded shortly before the rise of Islam, perhaps influencing the apocalyptic elements of early Islamic theology. The Quran itself, compiled in the decades after these events, contains numerous references to cosmic signs and celestial disturbances, to darkness falling, to stars losing their place, imagery that may have resonated with recent collective memory. Japanese chronicles mention strange lights in the sky during this period, blue fires dancing above the mountains, phenomena not typically associated with volcanic eruptions alone, details that don't fit neatly into the established narrative. These accounts were long dismissed as superstitious embellishments, as mythological interpretations of natural disasters. Yet modern science increasingly recognizes that myths often encode actual observations within cultural frameworks. The field of geomythology specifically studies how geological events enter mythological narratives, how catastrophes become encoded in cultural memory, how real events transform into symbolic stories that preserve their essential features across generations. Dr. Dorothy Vitaliano, who pioneered this field, argued that myths are the result of human attempts to explain phenomena that they cannot understand in scientific terms, making mythology a valuable, if complex, source of historical information. Physical evidence adds another dimension to these mythological accounts. Microscopic particles found in ice cores include not just volcanic material, but substances consistent with cosmic origin, a finding that continues to puzzle researchers. These particles include nanodiamonds, microscopic carbon structures formed under extreme pressure and temperature, conditions found in cosmic impacts or airbursts. Their presence in ice layers corresponding to the mid-6th century remains unexplained. Scientists from Dartmouth College identified these unusual particles, noting, their formation requires conditions not typically found in volcanic eruptions. Their presence suggests additional factors may have contributed to the 536 CE climate anomaly. In bog deposits across Europe, archaeologists have found what's called the 536-540 CE marker horizon, a distinctive layer containing unusually high concentrations of certain metals, including some associated with extraterrestrial material. Similar anomalous deposits have been identified in lake sediments from North America, from Asia, from Europe, all dating to this same critical period, all containing material that doesn't fit the purely volcanic explanation. These physical anomalies, combined with the mythological record, suggest we may need to expand our understanding of what occurred in 536 CE, to consider multiple converging factors, to examine possibilities beyond a single volcanic eruption. Could a cosmic event have triggered or coincided with volcanic activity, Could a fragmenting comet or asteroid have entered Earth's atmosphere? Could this explain both the historical accounts and the physical evidence? The debate continues. What's not debated is the catastrophic impact, the suffering that followed, the transformation of societies worldwide, the pivot point in human history that these events represent, a moment when everything changed. And as we're about to discover, the stakes were even higher than previously thought, the ramifications more profound, the legacy more enduring, the lessons for our own time more urgent than we might care to acknowledge. Chapter 7. Worlds Unmade. The true magnitude of the 536 CE catastrophe becomes clear when we examine its cascading effects, not just on climate, not just on agriculture, but on the very foundations of human civilization, on the trajectory of history itself. What began as an atmospheric anomaly triggered a domino effect of consequences, each amplifying the next, creating impacts far beyond what the initial event might have suggested, transforming societies in ways that would last for centuries. Recent research has revealed that the climate disruption was more severe and longer-lasting than previously understood. Ice core scientist Michael Sigl explains, "We're looking at the most severe and protracted cold episode in the Northern Hemisphere in the last 2,000 years. The temperature drop triggered agricultural collapse on an unprecedented scale. Crop yields fell by 30–80% in many regions. Grape harvests failed completely in some areas. Olive production plummeted. Grain stores depleted rapidly. Hunger became widespread." The Byzantine historian Procopius recorded that, "In this year a most dread portent took place, as a result of which came the greatest famine of all times," his clinical language masking the horrific reality of starvation that followed. Archaeological evidence confirms these accounts. Excavations across Europe show evidence of nutritional stress in human remains from this period. Stunted growth, malnutrition markers in bones and teeth, physical testimony to historical suffering. Anthropologist Patrick Geary notes, "We see clear evidence of physiological stress in skeletal remains from this period, including growth arrest lines in bones that tell us people were starving, then partially recovering, then starving again. A cycle of suffering." As food became scarce, social structures began to unravel. Evidence of hoarding appears in the archaeological record. Unusual caches of food and valuables. Changes in butchery practices to extract every calorie from livestock. Signs of desperate adaptation. Trade networks contracted dramatically. Mediterranean shipping declined by as much as 40%. Pottery distribution patterns show markets becoming increasingly localized. Luxury goods disappearing from provincial areas. Economic complexity simplifying. Archaeologist Christopher Lovelock explains, "We see evidence for the breakdown of long-distance trade networks, ceramic types becoming more localized, coin circulation decreasing, communities turning inward as systems of exchange contracted. Population declined sharply. Recent demographic modeling suggests the European population may have fallen by 25–50% in the decades following 536 CE. Through starvation, through reduced fertility, through migration, and soon, through disease. The climate catastrophe created perfect conditions for what followed. As weakened populations became vulnerable to pathogens, as people migrated in search of food, as sanitation collapsed, as communities crowded together, disease found opportunity. In 541 CE, just 5 years after the sun dimmed, bubonic plague emerged in Egypt. The Justinian Plague, first pandemic of Yersinia pestis, the same pathogen that would later cause the Black Death. Its timing no coincidence. The plague spread rapidly through the Mediterranean world, killing between 30 to 50% of the population in many areas, perhaps 25–50 million people total. Demographic collapse that would permanently alter the trajectory of European civilization. Recent genomic studies of plague victims from this period show that climate stress likely contributed to the pathogen's emergence and spread, environmental changes affecting rodent populations, disrupting ecological relationships, creating new disease vectors. The combined effects of climate catastrophe and pandemic transformed political landscapes. The Byzantine Empire, poised to reconquer the western provinces under Justinian, found itself demographically and economically devastated. Its imperial ambitions crushed. Historian Peter Heather argues, the climate crisis and subsequent plague effectively ended any realistic chance of Justinian restoring the Roman Empire, creating a power vacuum in the Mediterranean that would reshape the medieval world. Tax receipts from Egypt, the breadbasket of the Byzantine Empire, fell by 20 to 40% in the decades following 536 CE. Government revenues collapsed. Military capabilities declined. The empire's ability to project power diminished permanently. As traditional powers weakened, new opportunities emerged. The climate crisis hit different regions with varying severity, creating winners and losers, shifting the balance of power, opening paths for new political and religious movements. The Arabian Peninsula, less dependent on cereal agriculture, was less severely affected, creating conditions that would soon allow for Arab expansion, setting the stage for the rise of Islam. A world-changing development rooted partly in this environmental crisis. Historian Hugh Kennedy notes, the weakening of Byzantine and Sasanian power created a vacuum that the Arab conquests would fill. The emergence of Islam as a world religion might have followed a very different trajectory without the 6th century climate crisis. In Europe, the climate catastrophe accelerated the collapse of urban life. Cities contracted dramatically. Rome's population fell from perhaps 500,000 in its prime to around 20,000 by the end of the 6th century. Urban skills and technologies were lost. Archaeological excavations show layers of dark earth accumulating over Roman ruins. Once grand public buildings repurposed for humble dwellings, forums becoming grazing land, aqueducts falling into disrepair. The urban landscape transforming. Economically, the crisis disrupted monetary systems. Coin finds decreased sharply after 536 CE. Evidence of return to barter economies emerges. Economic complexity simplifying. Financial institutions collapsing. A reversal of centuries of development. Culturally, literary production declined precipitously. Fewer manuscripts, fewer inscriptions, reduced literacy rates, knowledge becoming concentrated in fewer hands, the written record itself thinning dramatically, information pathways narrowing. The climate disaster contributed significantly to what we now call the Dark Ages in Europe. Not through a single mechanism, but through cascading systems failures, each amplifying the next, creating a downward spiral of civilizational complexity. Kyle Harper of the University of Oklahoma argues, the 6th century climate crisis may represent the single most important environmental trigger in the transition from the ancient to the medieval world, a hinge moment in human history. The stakes were nothing less than the preservation of classical civilization itself, its knowledge, its technologies, its institutional structures, its philosophical traditions, its artistic achievements, all threatened by cascading system failures. Much was lost. Ancient texts disappeared. Engineering knowledge vanished. Medical understanding regressed. Architectural techniques were forgotten. Technological capabilities declined. Knowledge accumulated over millennia simply vanished. What survived did so largely through the efforts of religious institutions. Monasteries preserving fragments of classical knowledge. Islamic scholars translating and expanding upon ancient texts. Cultural transmission narrowing to a few tenuous pathways. Yet amidst this collapse, innovation emerged. Communities adapted. Agricultural practices changed. New social structures developed. Different political forms arose. Human resilience manifesting even in the darkest circumstances. The climate crisis forced agricultural innovation, the adoption of new crops, the development of the heavy plough, changes in land use patterns, adaptations that would eventually increase European agricultural productivity, but only after decades of suffering. Politically, the crisis accelerated the development of feudalism. As centralized authority weakened, as protection became localized, as communities bound themselves to local power holders, creating social structures that would define the medieval period. In China, the climate crisis contributed to the fall of the Northern Wei dynasty, to political fragmentation, to population decline, but also to adaptations that would eventually strengthen Chinese civilization. Different outcomes from the same global event. In Mesoamerica, evidence suggests the climate anomaly contributed to political reorganization, to changes in settlement patterns, to religious transformations. The effects global but filtered through local environmental and cultural contexts. The world that emerged from this catastrophe was fundamentally different, the trajectory of human civilization permanently altered, not just politically or economically, but philosophically, spiritually, in how people understood their relationship to nature and cosmos. And herein lies the most profound stake of all, the recognition of civilization's fragility, of humanity's vulnerability to environmental change, of how quickly complex societies can unravel when ecological foundations shift. A lesson with obvious modern parallels. The darkest year in history reminds us that we remain subject to natural forces, that climate change can trigger cascading societal failures, that pandemics can follow environmental disruption, that knowledge can be lost, that progress is not inevitable. But the story doesn't end with collapse. What follows is equally important. How humans adapted, how knowledge was preserved, how societies rebuilt, how new forms emerged from the ashes of the old. Resilience alongside vulnerability. And as our investigation continues, we discover the most stunning revelation of all, evidence that suggests the events of 536 CE weren't just a historical curiosity, but a warning, a preview of vulnerabilities that remain with us today, perhaps more than ever. Because the forces that darkened the sun in 536 CE haven't disappeared, they've merely gone dormant, waiting. And understanding what happened then might be crucial to surviving what could happen again. Lessons written in ash and ice, in genes and tree rings, in ruins and rebirth. Chapter 8. Competing theories. As we approach the heart of our investigation, several competing theories emerge to explain the catastrophe of 536 CE. Each supported by evidence, each with dedicated proponents, each offering different implications for how we understand this pivotal moment. The volcanic hypothesis remains the frontrunner, championed by paleoclimatologists like Michael Seigel and historians like Kyle Harper, supported by ice core sulfate deposits, by tree ring evidence of cooling, by historical accounts of dimmed sunlight. According to this theory, a massive eruption in Iceland ejected millions of tons of sulfur dioxide into the stratosphere, creating a veil of sulfate aerosols that circled the globe, reflecting sunlight back into space, cooling the planet for more than a year. This was followed by a second major eruption around 540 CE, possibly from a North American volcano, creating a 1-2 punch that extended and deepened the climate crisis, triggering the decade-long cold period visible in paleoclimate records. The evidence for volcanic activity is compelling. Ice cores from Greenland and Antarctica show distinctive sulfate spikes in layers corresponding to 536 CE and 540 CE, chemical signatures consistent with major eruptions. Timeline matching historical accounts. Tree rings from around the northern hemisphere show dramatic growth suppression beginning precisely in 536 CE, with a second growth reduction around 540 CE. A pattern consistent with volcanic winter conditions, supporting the double eruption theory. But questions remain. If an Icelandic volcano erupted violently enough to affect global climate, where is the thick ash layer in Icelandic soil profiles? Why haven't geologists definitively identified which volcano was responsible? Why do some chemical signatures seem unusual? Harvard University archaeologist Michael McCormick acknowledges these questions. We're still working to identify exactly which volcano erupted. The evidence points to Iceland, but the precise source remains elusive. The investigation continues. The second major theory involves cosmic impact, a comet or asteroid colliding with Earth or exploding in the atmosphere, an event that could also inject dust and aerosols into the upper atmosphere. creating similar climate effects. This cosmic hypothesis draws support from several lines of evidence. Unusual particles found in ice cores, including micrometeorites and nanodiamonds, elevated levels of certain metals in environmental samples from this period, historical accounts of astronomical anomalies. Proponents like astronomer Dallas Abbott of Columbia University point to historical accounts mentioning dragons in the sky and stars falling like rain. Interpreting these as descriptions of meteoric phenomena, eyewitness accounts of cosmic events. Abbott suggests the descriptions in historical sources sound remarkably like what witnesses of the 1908 Tunguska airburst reported. Bright lights in the sky, sounds like thunder, shock waves. These accounts deserve serious consideration. Environmental archaeologist Timothy Newfield notes anomalous traces in ice cores. We find unusual materials, including micrometeorites with composition suggesting extraterrestrial origin. These peak during the mid-6th century layers. It's a correlation worth investigating. The cosmic impact theory could explain certain anomalies. Why effects seem to begin so suddenly? Why some historical accounts mention phenomena not typically associated with volcanoes? Why certain unusual materials appear in environmental samples? However, critics point out significant problems. No impact crater from this period has been identified. The distribution pattern of climate effects better matches volcanic than impact scenarios, and major impacts typically leave more distinctive geological signatures. Paleoclimatologist Francis Ludlow argues, while we can't rule out some cosmic contribution, the preponderance of evidence still points to volcanic eruptions as the primary driver. The sulfate chemistry, the pattern of cooling, the duration of effects all suggest volcanism. Her third theory proposes a combination of events, a cosmic volcanic scenario where meteoritic impact or airburst triggered volcanic eruptions, creating a compound disaster with elements of both previous theories, a possibility gaining increased attention. Geologist Mark Boslow explains, "We know that seismic activity can trigger volcanic eruptions. A major impact or airburst could potentially trigger volcanic activity, especially in tectonically active regions, creating a cascade of environmental effects." This hybrid theory addresses some anomalies, explaining both the volcanic evidence and the unusual particles, accounting for the astronomical observations in historical accounts, offering a mechanism for multiple environmental effects occurring simultaneously. Recent research lends some support to this possibility. Studies of the Tunguska event show it could have triggered seismic activity. Analysis of other historical eruptions reveals some may have been triggered by external forces. The mechanism is scientifically plausible. However, geochronologist David Kring urges caution. While the combined scenario is possible, it requires an extraordinary coincidence. We should favor simpler explanations unless evidence definitively requires a more complex one. Occam's razor still applies. A fourth, more speculative theory involves solar activity, suggesting unusual solar behavior might have contributed to the climate anomalies, perhaps through a prolonged minimum in solar output, or through changes in cosmic ray flux affecting cloud formation. Proponents point to historical accounts of the sun appearing bluish or without brightness, to unusual auroral displays mentioned in Asian chronicles, to subsequent centuries showing correlations between solar minima and cooling periods. However, solar physicist Leif Svalgaard dismisses this theory. The climate effects were too sudden and too severe to be explained by solar variation alone. While solar activity does influence climate, it operates on different timescales and with different signatures. As we weigh these competing theories, patterns emerge. The volcanic explanation has the strongest empirical support. The cosmic theory addresses certain anomalies but lacks definitive evidence. The hybrid theory remains speculative but intriguing. What's not debated is the severity of the climate disruption, its cascading effects on human societies, its role as a tipping point in world history. These remain constant, regardless of which precise mechanism triggered the initial cooling. Perhaps most importantly, all these theories highlight human vulnerability to environmental catastrophe, whether triggered by terrestrial or cosmic forces, a vulnerability that persists today despite our technological advances. perhaps even increases with our global interdependence. The debate continues among scientists. New evidence continues to emerge. Analytical techniques continue to improve. The investigation remains active. The final verdict still pending. The mystery not yet fully resolved. What seemed clear becomes complex. What appeared settled remains contested. As is often the case in scientific investigation, certainty gives way to nuance. Simple narratives yield to intricate realities. The search for truth continues. And as we're about to discover, recent scientific breakthroughs have added new dimensions to this investigation, evidence that further complicates our understanding, findings that reveal connections previously hidden, discoveries that change everything we thought we knew. Chapter 9. Breaking New Ground. Recent scientific advances have revolutionized our understanding of the 536 CE event. New technologies, new analytical methods, new collaborative approaches, all revealing evidence previously inaccessible. Transforming how we interpret this pivotal moment in history, perhaps the most significant breakthrough came in 2018, when an international team led by Michael McCormick and Christopher Lovelock analyzed an alpine ice core with unprecedented precision, dating layers to the exact year, identifying their chemical composition. What they found stunned the scientific community. In the layer corresponding precisely to 536 CE, they discovered microscopic particles of volcanic glass, with a chemical signature pointing to an Icelandic source, the first direct evidence of the eruption's origin. Lovelock explains, using ultra-clean sampling methods and incredibly sensitive mass spectrometry, we identified volcanic shards with a geochemical fingerprint consistent with Icelandic volcanism. It's the smoking gun we've been seeking for decades, but paradoxes emerged immediately. The glass shards suggested an Icelandic eruption, yet the sulfate signature showed unusual characteristics. The glass composition didn't match perfectly with known Icelandic volcanoes. The mystery deepened even as evidence accumulated. Volcanologist Gil Plunkett notes, the chemical signature is tantalizing. It points to Iceland, but not to any volcano we've previously documented. It's possible we're looking at an eruption from a system that has remained dormant since. Meanwhile, genomic studies of the Justinian Plague revealed new connections. Analysis of ancient DNA extracted from 6th century plague victims showed the emergence of a new strain of Yersinia pestis, one that evolved shortly before the pandemic. Geneticist David Poinar explains, the strain that caused the Justinian Plague shows signs of having undergone recent evolutionary changes, changes potentially triggered by ecological disruptions that could connect directly to the climate catastrophe. This genomic evidence established a clearer causal chain. Climate disaster, ecological disruption, pathogen evolution, pandemic, a sequence with disturbing implications for our own time, for our own vulnerability to similar cascades. Even more surprisingly, ancient DNA studies of human populations revealed dramatic genetic bottlenecks during this period, evidence of severe population decline, of demographic collapse, genetic testimony to historical suffering previously known only through texts. Population geneticist Johannes Krause found, we see clear signs of population contraction in European genomes from this period. Genetic diversity decreases. Certain lineages disappear entirely. Biological evidence confirming historical accounts of demographic crisis. Paleogenomics also revealed unexpected population movements during this period, evidence of migrations not documented in historical sources, of people fleeing environmental catastrophe. Genetic signatures of displacement and resettlement across continents. These findings remind us that written history captures only fragments of human experience, that countless stories of suffering and survival went unrecorded, that the full human cost of the 536 CE catastrophe exceeds what any chronicle could convey. Archaeological science has contributed its own revelations. Analysis of thousands of coins from this period shows dramatic reductions in silver content, evidence of economic stress, of monetary systems under pressure, of resources becoming scarce. Archaeometallurgist Kevin Butcher explains, the silver content of Byzantine coins drops precipitously after 536 CE. The empire was literally diluting its currency, a smoking gun for economic crisis that aligns perfectly with the climate catastrophe. Isotope analysis of human remains reveals changing diets, evidence of adaptation to food scarcity, of communities abandoning preferred foods for whatever was available, of nutritional stress affecting entire populations, biology recording what texts often omit. Bioarchaeologist Sabine Kaki found stable isotope signatures in bones from this period show dramatic dietary shifts. People were eating whatever they could find, evidence of crisis that's written in the very chemistry of human remains. New palynological studies, analysis of ancient pollen, reveal abrupt agricultural collapse. Cereal pollen disappearing from the record. Forest species returning to previously cultivated areas. Landscape changes reflecting human withdrawal. Nature reclaiming abandoned farms. Paleoclimatologists have reconstructed temperature changes with increasing precision, showing the 536 CE event caused cooling of 1.5 to 2.5 degrees Celsius within months. A rate of change with few precedents in the Holocene, a shock that human systems couldn't absorb. For context, the difference between current global temperatures and the last ice age is about 5 degrees Celsius. The 536 CE cooling represents roughly half that difference, occurring not over millennia, but within a single year. A climate shock of extraordinary magnitude. But perhaps the most puzzling new evidence comes from cosmochemistry, analysis of ice core samples, using techniques developed for studying cosmic dust, revealing elevated levels of elements typically associated with extraterrestrial material. Precisely during this period, geochemist Mikhail Petaev identified elevated levels of platinum group elements in ice layers from 536 CE, elements like iridium, more common in meteoric material than in Earth's crust, suggesting a possible cosmic component to the catastrophe. These findings don't negate the volcanic evidence, but they do suggest a more complex scenario, perhaps involving both terrestrial and cosmic factors, a possibility that remains controversial but can't be dismissed outright. A mystery still unfolding. The paradoxes multiply. Volcanic evidence is clear but incomplete. Cosmic indicators are present but inconclusive. Historical accounts describe elements of both. The full picture remains elusive. The investigation continues. What's increasingly clear is that we're dealing with an environmental catastrophe of unprecedented complexity, one that affected climate, ecology, agriculture, economics, politics, religion, and disease ecology. A systemic crisis that transformed societies across continents. Recent modeling of climate impacts shows the effects were not uniform. Some regions suffered more than others, creating winners and losers, reshaping power relationships, setting the stage for political transformations that would define the medieval world. Climate scientist Ulf Bündgen explains, "Our high-resolution models show that while cooling was global, some regions experienced more severe effects than others, creating differential impacts that helped reshape the geopolitical landscape for centuries to come. Archaeological evidence reveals how communities adapted, some successfully, some not, with technological innovations emerging from necessity, new agricultural practices, new social arrangements, new survival strategies, human resilience amidst catastrophe. The emerging picture is one of interconnection, of cascading effects across natural and human systems, of complex feedbacks between climate, ecology, agriculture, economics, demographics, politics, and disease. A web of relationships we're only beginning to understand. This interconnected perspective transforms how we interpret the historical impact, moving beyond simple cause-effect relationships, recognizing systemic vulnerabilities, appreciating how multiple stressors can combine to trigger civilizational tipping points. These insights have profound implications for our own time, for our own vulnerabilities, for our own interconnected global systems, for our own potential tipping points. Lessons from the past that speak directly to present concerns. As our investigation reaches its climax, we stand on the threshold of understanding, of grasping not just what happened in 536 CE, but why it matters, what it means, how it changed everything, and what it might tell us about our own future. Chapter 10. The Darkness Decoded. After weighing all the evidence, consulting experts across disciplines and considering competing theories, we can now piece together what most likely happened in 536 CE, the catastrophic sequence that plunged the world into darkness and changed the course of history. The primary trigger was indeed volcanic, a massive eruption in Iceland around early 536 CE, likely from a volcano in the Vatnajökull system, one that ejected millions of tons of sulfur dioxide and ash into the stratosphere. Recent geochemical analysis of volcanic glass particles found in ice cores points specifically to this source, the chemical fingerprint matching Icelandic volcanism. Though the specific volcano remains unidentified, possibly one now dormant or changed by subsequent activity, this eruption created a stratospheric sulfate aerosol veil that spread globally, reflecting sunlight back into space, cooling the planet rapidly, creating the dark sun described in historical accounts, triggering the climate anomalies recorded in tree rings. But this was just the beginning. The evidence suggests a compound disaster, a sequence of events rather than a single catastrophe, with timing that couldn't have been worse for human societies already stressed by political and economic challenges. In 540 CE, as communities struggled to recover from the initial disaster, a second massive eruption occurred, possibly from a North American volcano, though its precise location remains uncertain, creating a second wave of global cooling, extending the climate crisis. This double eruption scenario explains the extended cold period visible in paleoclimate records, the decade-long depression in temperatures, the prolonged agricultural failures, the compounding effects that pushed many societies beyond their capacity to adapt. But the story contains another crucial element, one that explains some of the anomalies in our evidence: the cosmic material found in ice cores, the unusual astronomical phenomena mentioned in historical accounts, a possibility only recently taken seriously. During this same period, Earth appears to have encountered a period of unusual cosmic activity, possibly intercepting a stream of cometary debris. Not a single large impact, but multiple atmospheric events over months or years, contributing to the environmental effects. Dr. Dallas Abbott explains, the evidence suggests Earth passed through a dense stream of cometary material, creating numerous airbursts and meteor showers, not enough to cause catastrophic damage individually, but collectively contributing to atmospheric loading. This explains accounts of dragons fighting in the sky, of stars falling like rain, of unusual celestial phenomena preceding and accompanying the darkness. Eyewitness descriptions of actual astronomical events interpreted through pre-scientific frameworks. It also explains the presence of cosmic material in ice cores, the elevated levels of platinum group elements, the nanodiamonds, the micrometeorites with unusual composition, physical evidence supporting historical accounts previously dismissed as superstition. The combination of volcanic eruptions and cosmic activity created a perfect storm of atmospheric effects: sulfate aerosols from volcanoes, dust from cometary material, perhaps even interactions between them enhancing their cooling effects. A compound atmospheric catastrophe. This convergence of terrestrial and cosmic factors produced climate effects more severe and complex than either would have alone, explaining the unprecedented nature of the climate anomaly, its unique signature in paleoclimate records, its devastating human impact. But the most profound revelation concerns what followed, how this climate catastrophe triggered cascading effects across human systems, creating vulnerabilities that led to the next disaster, the Justinian Plague that struck in 541 CE. New genetic research has established a clear connection. The climate crisis disrupted ecosystems, altered rodent populations, created new pathogen host dynamics, generating conditions for the emergence and spread of Yersinia pestis, the bacterium causing plague. This pandemic struck populations already weakened by years of malnutrition, already stressed by economic contraction, already destabilized by political upheaval, creating a demographic collapse that would permanently alter the trajectory of European civilization. The combined effect of climate catastrophe and pandemic reduced the European population by 30–50%, ended realistic hopes of restoring the Roman Empire, accelerated the transition to medieval social and economic structures, transformed the Mediterranean world. But the most significant revelation is what this tells us about civilizational vulnerability, about the interconnected nature of environmental and human systems, about how quickly complex societies can unravel when faced with multiple converging stresses. The 536 CE event wasn't just a climate anomaly. It was a systems collapse triggered by environmental shock, a demonstration of how dependent human societies remain on stable environmental conditions, on predictable seasons, on reliable harvests. This realization has profound implications for our own time, for our own global civilization, for our own interconnected systems, for our own environmental challenges. The past speaking directly to present concerns, ancient catastrophe illuminating current vulnerabilities. Today we face climate change occurring at rates comparable to what happened in 536 CE. We face potential pandemic diseases. We face possible disruptions from both terrestrial and cosmic sources, while our global population and infrastructure are more vulnerable than ever. Yet we also possess advantages our ancestors lacked: scientific understanding, technological capabilities, early warning systems, global communication, resources for adaptation, if we choose to use them, if we heed the warnings from the past. The lesson of 536 CE isn't just that catastrophe can happen, it's that complex civilizations can be more fragile than they appear, that multiple stresses can trigger cascading failures, that recovery may take centuries, that what's lost may never be recovered. But there's another lesson, about human resilience, about adaptation, about survival, about how societies transform under pressure, how innovation emerges from necessity, how new structures arise from the ashes of the old. The world that emerged from the catastrophe of 536 CE was fundamentally different. The Mediterranean never again centered the Western world. European society reorganized along feudal lines. New religious and political movements emerged. Human history pivoted. What seemed apocalyptic to those living through it was, in historical perspective, transformation rather than ending. Painful, costly transformation that claimed countless lives and erased countless achievements. But transformation rather than extinction. This offers both warning and hope for our own time. Warning about our vulnerabilities, hope about our capacities. Recognition that while civilizations may fall, humanity adapts. Though never without suffering, never without loss, never without cost. The year 536 CE was indeed the darkest year in recorded history, a moment when everything changed, when the sun itself seemed to fail, when the orderly progression of seasons collapsed, when the foundations of civilization trembled, and its darkness continues to illuminate our understanding of natural disasters, of human systems, of historical turning points, of civilizational vulnerability and resilience, a distant mirror reflecting our own potential futures, both dark and light. Dark. The story of 536 CE reminds us that history isn't just a steady march of progress. It's a complex dance of advance and retreat, of creation and destruction, of resilience and vulnerability. A path not always forward, but sometimes sideways or backward. We stand now at our own historical crossroads, facing our own environmental challenges, our own pandemic threats, our own societal stresses, with both greater capabilities and greater vulnerabilities than our ancestors, with both more to lose and more to save. The darkness of 536 CE passed eventually. The sun returned to full brightness. Temperatures gradually warmed. Societies adapted or transformed. Human ingenuity found new paths forward, though not without enormous cost, not without permanent losses. As we face our own uncertainties, the lesson isn't simply that disaster can happen. It's that understanding our vulnerabilities may help us address them, that recognizing our interdependence may help us strengthen it, that remembering our history may help us shape our future. Perhaps most importantly, the story of 536 CE teaches us humility, about our place in the cosmos, about our dependence on natural systems, about the fragility of what we build, about how quickly certainty can become chaos, prosperity can become scarcity, order can become disorder.